Star School students, yesterday we saw the exercise number 5.1 which was related to line segment. Now today we are going to see about exercise number 5.2 which is based on angles. Let me start exercise number 5.2. First sum. What fraction of the clockwise revolution the horn hand of a clock turn to when it is when it goes from the following questions. What the fraction of the clockwise revolution the horn hand of a clock turns to when it goes from given question? Let me take the first subdivision. Three to 9. So we have to find the revolution of 3 to 9. First let me draw the diagram of clock. This is a clock. We have to draw the diagram 3 to 9. So 3 to 9. Okay. First, this move to 3 to 9. Move from 3 to 9. This is a one revolution. That is right angle. Already you learned types of angle. 90 degree. Right angle means 90 degree. There is another name to call to define the right angles. We can say 1/4 revolution. We can write as 1/4 revolution. Next, this is another right angle triangle. So we can write this also 1/4. So 3 to 9 means we get the half revolution. This is 1/4. This is 1/4. So we can add these two numbers. 1/4 revolution. So denominator is same. So we can add the numerator 1 plus 1 divided by 4. 1 plus 1 is 2. 2 by 4. We can cancel the in two tables. So 2 ones are 2. 2 2s are 4. We get 1 by 2. Okay. So this is half revolution. So 3 to 9 means we get 2 right angles. Okay. How many right angles? 2 right angles. Or we can write half revolution. Half revolution. Okay, are you clear? Next, let's move the D subdivision. That is nothing but 12 to 9. Here we can move 12 to 9. So we draw. We have to find how many revolutions or how many right angles. So 12 to 9 means we have to move clockwise direction. That is, this is clockwise direction. So 12 to 3 is one right angle. Next 3 to 6 is second right angle. Next 6 to 9 is 3 right angles. So we have to add, we have 3 1/4 revolution. 1 by 4 plus 1 by 4 plus 1 by 4. So we can add these 3. So 1 plus 1 plus 1 divided by 4. So we get 3 by 4. So in this manner we have to find 3/4 revolution. Okay. So here twelve to 9 means we got 3 right angles. 3 right angles, that is 12 to 3, then 3 to 6 and 6 to 9. Okay. Or we can say 3/4 revolution. Both are same. Okay, next let's move the next subdivision, that is F. F is 6 to 3. We have to move from 6 to 3 in clockwise direction. So we can start from 6 to 3. 1, 2, 3. This is one right angle. This is one more right angle. This is also one more right angle. So here 3 right angles were covered in this case. So here also we follow the same method. We get 3/4 revolution. So 6 to 3 means it has 3 right angles. And 3/4 revolution. Hope that you understood. Next let's move second problem. Second question. Where will the hand of a clock stop it? Then we take the first subdivision. Starts at 12 and make half of the revolution. Half of the revolution stops. Half means it covered 2 right angles. See this, time starts from 12. Okay, and make half of the revolution. That is, dash 2 right angle. This 1, 2. Here we have to stop 6. Here when we move 3 numbers or 15 minutes, we make 90 rotation. This is also means 1/4 revolution. So we stop at 6. Let us look at the next part of this question. D subdivision. If hand starts at 5 and makes 3/4, 3/4 of a revolution. What do you mean by 3/4? It covers 3 right angles. Okay. Stop. So the clock starts at 5. So here 5 is here. So we can make 4 right angle. These are the 4 right angles. It starts from 5. So we can make 3/4 of revolution. This is 1/4. This is one more right angle, that is half of the revolution. Next third, that is 3/4 of revolution. We can stop. One right angle is covered 5 to 8. Next 8 to 11. Then 11 to 2. So it stop at 2. Stop at 2. Next we can move the fourth sum. What part of revolution have you turn through if you stand facing. Let me take the first subdivision. East and turn clockwise to face north. These are the 4 directions that we have. Okay, clockwise. Clockwise means along the directions of hand of the clock. So actually move like this. Anti-clockwise means it is opposite to clockwise. It can move like this. Okay. So we have to start from east and turn clockwise to face north. So we have to move from east to south, then south to west and west to north. So from this problem we have turned through a right angles. First you stand facing the east. Then by a right angle turns clockwise, you now face south. By another right angle turns, you finally face west. Then we move. You have to face north. Okay, so we need 3 right angles. The answer is 3/4 revolution. Next, let's move homework problem. This is your today's homework. In first sum, you have to solve B, C and E subdivision. In second sum, B and C subdivision. And fourth sum is B and C subdivision. Okay, thank you students.
Have you ever observed the hands of a clock? The two hands are at different positions at different points of time as they move along the dial. The two hands represent two rays meeting at a point. When two rays have a common end point, they form an angle. The two rays forming an angle are called the arms of the angle. The common endpoint is called the vertex of the angle. We measure angles in degrees. To measure an angle, we use an instrument called protractor. It is in the shape of a semicircle. The midpoint of its horizontal edge is called its central point. The angle at the center is divided into 180 equal small divisions. A complete turnaround point is divided into 360 equal parts. Each of these parts is called a degree, to be denoted by 1 degree. As you can see, the arms of the angle can take any position. Say 30 degree, 40 degree, 50 degree, 75 degree, 190 degree, 245 degree. Depending on the position of the arms, there are different types of angles. Let's learn about them. An angle whose measure is more than 0 degree and less than 90 degree is called an acute angle. Acute angle? No, it's acute. Acute angles are smaller than other angles. An acute angle whose measure is 90 degree is called a right angle. All right. Right angles are larger than acute angles. Obtuse angles are bigger than right angles. They measure between 90 degree to 180 degree. What will happen if both the arms of the angle are in an opposite direction? Nothing. There will be no angle. Wrong. This type of angle that measures 180 degree is called a straight angle. Let's move the arm of an angle to more than 180 degree. An angle whose measure is more than 180 degree and less than 360 degree is called a reflex angle. Okay, what will happen if both the arms of an angle overlap each other? 0 degree, 360 degree. Yes, both are correct. An angle that measures 0 degree is called zero angle. When the arm takes a complete turn, then an angle of measure 360 degree is formed. This type of angle is called a complete angle. Let's have a quick review. Acute angle, right angle, obtuse angle, straight angle, reflex angle, zero angle, complete angle.